In the last video, we looked a bit more closely at rhythm, and specifically the idea of simple meter. If you have not yet watched that video, I recommend starting there, as this video will build on the concepts introduced there. As a brief recap, simple meter divides each beat into 2 equal parts. By contrast, compound meter divides each beat into 3 equal parts. So how does this relate to what we learned about simple meter? Well, to begin, we need to understand the function and purpose of the dot. Adding a dot to a note alters the length of that note. Specifically, it adds exactly 1/2 of the value of the note. Remember that a quarter note is made up of 2 eighth notes. Putting a dot on that quarter note would add 1 additional eighth note to its length. So in 4/4, instead of lasting 1 beat, the dotted quarter note would now last 1½ beats. The same principle can be applied to other notes. Dotting a half note would add a quarter note. Now instead of 2 beats, it would be 3. Take a second to work more on this if it is unclear, as this is going to be very important to understanding compound meter. So, as stated earlier, compound meter divides each beat into 3 equal parts. Let's look at a measure of 6 eighth notes. This measure could be in simple meter if we group them in pairs, and the resulting time signature would be 3/4, 3 groups of quarter notes in each measure, feeling the quarter note as the beat. But what if we group them in threes instead? We haven't changed the number of eighth notes in the measure, but now it is compound instead of simple. So what sort of note would we feel as the beat now? Remember our work with dots a little while ago. We are looking for a note that is equal to 3 eighth notes. 2 eighth notes is a quarter note, and the third eighth note is half of a quarter note, so we can use a dotted quarter note to represent our beat in compound meter. In this case, there would be 2 beats per measure. Now for the big question. What goes in the time signature? We've already determined that the bottom number has to be a power of 2, so there is no single number that can represent a dotted quarter note. To keep it simple, we just count the eighth notes. There are 6 of them here, so we call it 6/8. Notice how the grouping of the eighth notes is of utmost importance. Without these beams showing the groupings, it would be very difficult to know whether this measure is 3/4 or 6/8. The difference is more audible by emphasizing the first note of each group. Some composers use this element of ambiguity to make really fun rhythms.
I like to be in America, okay by me in America.
Like with simple meter, we can change what note we count as the beat. If we divide into eighth notes, we count a dotted quarter note as the beat. If we divide into quarter notes, we count a dotted half note as the beat. If we divide into 16th notes, we count a dotted eighth note as the beat, and so on. When we looked at simple meter, the top number could be anything. But with compound meter, we are limited to numbers divisible by 3 because of how we divide each beat. For that reason, you will frequently see 6, 9, or 12 on top, which most closely relate to the simple meter groupings of 2, 3, and 4, respectively. Only the beat divides into 3, though. If we go up to the macro beat level or down to the subdivision level, we still divide into 2 parts, so that each beat has 6 subdivisions, not 9. And that's pretty much it. Compound meter can be described as lilting due to the uneven nature of the division, and you'll often hear iambic rhythm patterns, that is long, short, etc. Stay tuned for more videos dealing with theory fundamentals, and I'll see you next time.